Akami is the world's best kept billion-dollar secret. We're the largest global platform of shared computing. If you look at how we do it, we deploy thousands of servers close to the end user and close to the ISPs themselves. Now, last year when I sat in front of you, we had about 85,000 servers. Now we have over 200,000 servers. We're really investing heavily in our infrastructure, mainly because of the demand that video now is placing on the internet itself. It used to be where you just watch that little teeny YouTube clip, and how much bandwidth did that take up, right? Now we're watching high-definition movies. So it's really clogging up the pipes. There's a big demand for internet traffic now, not only for recreational use, but now corporations are using it too. It's a viable business tool. We have those 100,000 servers deployed in 2,500 locations, and they're in 1,100 ISP networks. So 90% of the world's internet users are going to be within one network hop of our network. So we're going to be in the Verizons, we're going to be in the AT&Ts, but we're also going to be in the Deutsche Telecoms, the Singtels, and you're going to find us in Joe and Mary's ISP out in Duluth. We're going to be in the small ones, the big ones, across the globe. We're transparent to the end user, so you use us every day, you don't realize we're there. We're pushing and accelerating 20 to 30% of the world's internet traffic on a daily basis. That works out to something like, I think, close to 50 petabytes a day. So the two key markets Akami focuses on, the B2C and B2B. This is really where we kind of cut our teeth, what we call cacheable content. For instance, and this example would be like a corporate website. And then you start getting into more dynamic, non-cacheable. This is where we kind of differentiate ourselves from the competition. You know, caching video, that's kind of really being commoditized nowadays, but the dynamic content is where businesses are going now that's non-cacheable. We have ways to accelerate that content as well. So the business trends. Companies right now, they're trying to webify their applications. You have a decentralized user base. No one's sitting in an office anymore. Everyone's scattered around the globe, right? Companies are looking to centralize their infrastructure. And of course, security always becomes a concern, DDoS protection and virus protection. And applications like virtual desktop. And the other one here is handheld devices, right? We don't sit at a laptop anymore. We use different ways to connect. We're not in an office. We're not sitting at a desktop. We're on a laptop. We're on a smartphone. We're on some type of tablet. So what happens with IT infrastructures and IT folks that are faced with webifying these applications? There's some inherent issues with the internet that's really prevented companies from doing this in the past. Number one is latency. The farther you get away from your data center, the speed of light issues, right? Number two would be inefficient protocols. You have very chatty protocols, a lot of handshaking back and forth, a lot of round trips. Number three is network anomalies, packet loss. Now this is the hidden one you can't really measure. You can always check out your latency, but how much are you actually losing in packets? So in the old days, when we went to deliver applications, we built a corporate WAN, and we're all familiar with this. This is your MPLS grid. How do we optimize that? Well, we know how to do that. We use Silver Peak, we use Riverbed, we use Cisco. We put some type of appliance at one end and another appliance on the other. We optimize that connection. And it overcomes a lot of those problems we just mentioned, like latency and packet loss. And what you cannot do, though, is address these remote users. So this works great for your fixed locations, your branch offices, your call centers, people who are sitting in an office. And a guy like me, for instance, my MPLS when I'm in the office works great for the 3 days a month that I'm in the office. But what about the other 27 days? I'm one of these guys up here, right? I'm one of the moving targets that doesn't sit in an office. But I need those applications just as bad on those 27 days I'm not in an office, so I'm at the mercy of the internet. And if you look at this picture right here, you can see that we're going to be very close to your origin, but we're also going to be very close to your end user, no matter where that end user pops up. And that end user could be a customer, could be a business partner, could be your employees. So why can't we just optimize the internet with a couple of Riverbed appliances or a couple of Silver Peaks? Well, you really got to understand where the problem lies. The problem with the internet lies in the middle mile. You can't optimize the first and last mile because 95% of the issue is in the middle. And that's where appliance has no control over. And to understand why that works is really have to understand the internet itself. Now you see the picture of the cloud, right? We've all drawn the picture of the cloud. I remember back in my storage days we drew clouds. And why do we draw clouds? Because they're nice and safe, they're cute. But really no one knows what goes inside of that cloud, right? Well, it's pretty confusing. And this is the inherent issue of the internet. You have peering relationships. Comcast peers with Verizon, AT&T, Level 3, XO Communications, Singtel, you name it. You have all these different ISPs pairing and pushing traffic together. Pairing relationship basically means I'm going to pass you traffic, you're going to pass me traffic, and we're not going to charge each other. But if you start pushing me too much traffic, I might shut the door and not take any more traffic from you. Peering relationships don't always work. So what happens to your traffic is it doesn't go in a straight line. It bounces around from ISP to Tier 1 to Tier 2 to Tier 3. Cedric might remember some of this from his Verizon days, right? There's no economic basis on this work. Because it's free, it doesn't really care how long it takes to get there. In fact, if we look at this model again, it doesn't even care if it gets there at all. Sometimes your traffic just disappears. It's too bad it was a free of charge service. Go back and ask for it again. Those are the inherent issues you have with the internet. Now, some of the issues we kind of go around, you might have heard of PGP, Border Gate Protocol. Now, that doesn't take into consideration congestion. So how do we overcome that in the past? Well, if you look at this application hosted on the East Coast, you can see that the speed of light issues, the farther you get away from that data center, the worse the application started performing until basically you get into the red and it's unacceptable, unusable, right? And you can see it just basically follows itself around the globe until you get someplace like Asia, and it's even worse. So we overcame that by deploying data centers in multiple continents, get closer to eyeballs, right? So we drop a data center perhaps down here in Latin America. We're going to probably need one in EMEA. We're going to put one over here in Asia. And that helps a little bit. But you know what? Asia's a big place. If you put a server in a data center in Tokyo, it's not going to help your users in Sydney or Singapore or even China. So you start adding multiple data centers. It becomes a very expensive proposition to support. Now, we take that same scenario. It could be any of these business applications that we're talking here. It could be your SAP, could be Oracle, could be Microsoft. If you Akamize those applications, keeping it centralized just in one data center, you can see even though you're getting farther and farther away from the data center, that line stays pretty consistent. We're flattening the world. So I feel like I'm right next to that data center, whether I'm in the East Coast, the West Coast, Europe, or even Asia, without having to replicate that data center. So if we look like a prime example like HP and Cisco, some of the partners that you do business with that do business with us, Cisco, for instance, 15 of their B2B applications run on Akamai. So Cisco doesn't have to replicate those applications in multiple data centers anymore. They can run that out of one centralized data center, probably a primary and a secondary, but they don't have to build several of them all around the globe and support those. So how do we do this? All right, what's the magic inside that cloud? Those 100,000 servers deployed close to your end user and close to your data center, basically they're always pinging the internet. They're running races through the internet to find the fastest route from point A to point B, and also C, D, and E, F, and G. So we're looking at the fastest internet race. Now, the most direct route might not be the fastest, and this might be BGP, for instance. It's like everyone jumping on the freeway at the same time. Is there a better route to get from here, point A to point B? Because we're pinging the internet, we see that this PGP route isn't efficient. And about 80%, actually it's close to 90% of our traffic doesn't go PGP. We have to take alternate routes with our traffic. So we realize, yes, maybe we're taking a little bit farther of a distance to get there, but the traffic's getting there much quicker than it would on this route, over 2 times faster in this example. How are we going to accelerate this? You know, it's no longer a question of, do I use the corporate WAN, the MPLS, or do I use the internet? It's really going to be a combination of both. Even applications like VDI, for example, they're really built to be mobile, right? So when working in the office, that's great. We connect to the MPLS grid, and we connect to our data center. Pretty simple. We optimize that with build this out a little bit, with a few WAN optimizations. We have this one pretty much figured out. This is what we've been doing for years. But as the business evolves and changes, you need to address the performance for your remote users. And those remote users could be your employees, but they could be your business partners, they could be your customers. With Akamai, you have the ability to deliver those applications and still have WAN-like, MPLS-like performance without being tethered to that point-to-point connection. Time to market also becomes an issue. So if you have, perhaps you have a data center here in California and you have some developers working for you in India, and a new project arises, and maybe you're doing some type of SharePoint collaboration tool. Instead of deploying an MPLS circuit to India, which could take you several months to deploy, it's going to be a pretty hefty sum to do that. The alternative is, well, let's see if we can leverage the internet. IT folks are a little reluctant because the internet has a reputation of being slow and unsecure. Akamai overcomes that. So not only do we give you that connection to India, but you're not tethered to that point-to-point. So maybe if you start hiring developers in Eastern Europe or China or wherever, they can use the same Akamai service. You're not tied to that point-to-point like an MPLS. It's flexible. Essentially, you can get to all those 2,500 locations that were scattered across the globe and leveraging that infrastructure. You know, we're virtualizing everything these days. You don't want to own the hardware. Now, why would you want to own the network connections when you can virtualize that as well with a SaaS provider like Akamai? One of the inherent issues is always security with Akamai, with the internet. Akamai helps you overcome that because now you're actually absorbing some of that traffic at the edge, some of the problems of DDoS attacks. You still have the secure connection with an SSL VPN. So instead of MPLS, you deploy SSL, so you still have that secured connection, and it's encrypted. So it's just an added. Right. But the other thing would be DDoS attacks. So we're actually stopping those attacks at the edge. It's not going to replace the hardware that you're going to deploy in your data center, but wouldn't it be nice to stop the bad guy before he got in the plane instead of waiting until he knocked on your door and stopping him at the front door? We're stopping him before he even gets on the plane. We're absorbing that attack at the edge.